Okay, guys, we are looking at lesson 1.3 today, which is piecewise defined functions. They're piecewise defined functions because they are in pieces. Okay, so the graphs are going to kind of look a mess. Okay, there's a piece here, a piece there, a piece, just multiple pieces wherever. The equations are in pieces also. Okay, so like this one, f of x is defined to be 3 different things. So my graph is 3 different pieces. Okay, so piecewise function has different rules for different parts of its domain. So the idea here, like f of x equals 7. Well, remember we talked about f of x is another way to say y. Okay, we talked about that. So this is like the red here, and I know yours isn't in color, but if you look at mine, the red here is like y equals 7. So y equals 7, when it's y equals a number, what is that graph? When it's y equals number, it's just a horizontal line. So you'll notice right here, and I'm going to erase this, but there's that horizontal line, yes? Mm-hmm. The key is I just drew the whole thing. Like that whole thing would be y equals 7. But you'll notice on the graph, we only have a portion of it. And the idea is then it's 7, but it's defined to be between when x is between -5 to -2. So that's, okay, on the x-axis, -5 to -2, that's where that line exists. So you're only doing a piece of that line. Then you've got the blue line, 5 minus x. Well, we're going to talk about y equals mx plus b today. Y-intercept of 5, slope of -1, that's that piece. But it only goes from -2 to 3. And you've got the green line, 2x minus 3. So if you extended this as a slope of -2, and it would intersect -3. But the only piece you can see is the piece that goes from 4 to 6. Okay? So we're looking at pieces. So our first practice is we're going to try and draw one. Okay? We're going to try and draw one. I mean, I can sit here and point at this one all day, but we really just need to jump in and figure out how to draw the pieces. So we're being asked to graph the piecewise defined function, and at the end, we'll have to state domain and range. Okay, they don't let us get away without that. So f of x is equal to, and you'll notice there are 3 different lines. So that means we're going to draw 3 different pieces. So let's start with the first piece. It just says 3. Keep in mind that's like f of x equals 3, or I'm going to think of it as y equals 3. Now, we talked about what y equals a number looks like, so that might help you. The other thing is, do I dare say all, or is it just most? Most, if not everything we do today, is y equals mx plus b. Okay, do you guys remember anything about y equals mx plus b? Yeah, most of what we're doing is y equals mx plus b. Now, with this one, we just have a 3. So if I wanted an x, I would have to say y equals 0x plus 3. Okay, if we wanted an x, we'd say y equals 0x plus 3. But what's that mean? The b value, the 3, represents the y-intercept. The m value in front of x represents the slope. Well, a y-intercept of 3 is going to cross the y-axis at 3. What's the slope of 0 look like? Hello? Olivia Orberson? Okay, so that would explain why she was having problems this morning. Okay, did she come to you about it? Okay, and I said, well, I didn't think she would be part of the bigger problem going on, but. Okay. is part of the group. Interesting. Okay. Well, and I almost sent it to you to have you check it out, but I didn't, so. Okay, does she know that then? Okay, that's why it is. Okay. Okay, thank you very much. Bye. Okay. So we said y-intercept at 3, which means y-axis. We're going to go up 3. Now, slope of 0 says a flat line. Don't draw this whole thing yet, but generally speaking, what's it look like? Don't draw that though. But that's what it looks like, yes?
Yeah.
Do I need that whole thing? No. I only need that line from what?
-4 to -1.
-4 to -1. So now, okay, let me undo my piece. We want that line, okay? So it's the idea of, we're up here at 3. I'm going to put some light dots. I'm not going to keep them all, but, that's kind of the idea of where we are. We only need it from -4. When is x -4? -4 to -1 on the x-axis. So we only need that piece right there. Okay. These other pieces, these other little dots I put in, yeah, I don't need them. Okay. Now, as we draw these pieces, and I didn't talk about up above, but if you looked back up above, sometimes there were nice, neat endpoints. Other times there were open circles. How do we decide what I need on each end, whether they're filled in circles or they are open circles? Do we remember, Thomas?
It has to do with like the greater than or less than sign. Like if it's if it's just greater than or less than, it's a solid. But if it's is it flip flop? Flip flop. So if it's greater than or less than, it's like just a circle. If it's greater than or equal to or less than or equal to, then it's solid.
Yeah. Do you guys remember this? This is old news. So anytime you see less than or equal to or greater than or equal to, you're going to be using a filled in circle. Anytime you see just less than or greater than, it's going to be an open circle. Now, we talked about that a little bit back in 1.1, I think. Or I kind of, mentioned a little bit, but now we're definitely talking about. So, at -4, do we have the equal to piece? No, it's just -4 less than x. So at the -4 end, I'm going to use an open circle. So I'm not filling it in. At the -1 end, notice it's x less than or equal to -1. So at the -1 end, you're filling that circle in. Okay? That's like part 1 here. Now we do the next piece. I personally am changing colors just because. My next piece says y equals -x. Now, if we're thinking mx plus b form, we have an x plus what? Plus 0. Okay, -x plus 0. So what do we know here? We have a y-intercept of 0 and a slope of what? -1. There's an invisible 1 there, isn't there? Okay, what's our phrase for slope we can use? Yep. We talked about that the other day, didn't we? So we can do a rise over run for our slope. What is -1 as a fraction? -1 over 1. So now, don't draw a whole big line yet, right? Because we're only going to need parts of it. So just be aware of that. But a y-intercept of 0 means I'm thinking about, okay, my starting point is here. Rise -1, run 1 means I need to go Rise negative 1 is down 1. Run 1 is right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Do I need all of these dots? No. You can also reverse it and go up 1, left 1. Up 1, left 1. Okay. I'm just kind of putting my line in place. I don't need all those dots though, because we have a restricted domain. What is my domain piece here? Now we're looking at all x's between 0 and 2. Okay, so we know where 0 is, right? Where's 2? 1, 2. I only need the piece of the line that goes from 0 to 2. So I only need that piece of the line right there. Does that make sense? Okay, now I know I don't know if you're putting those extra little dots in, you can take them out if so. I mean, if they're light enough, they could stay in and it won't matter, but. Okay, endpoints. Can you figure out endpoints? 0 less than or equal to x, less than or equal to 2.
Close.
Okay, they both have the equal to, so they're both closed circles, filled in circles. Make them obvious. Make the points there so we know. And piece 3. Ready for piece 3? Our other piece, y equals negative x plus 3. This is good Algebra 1 review of graphing y equals mx plus b, yes. 3 is my y-intercept, and my slope is negative 1. So again, that slope of negative 1 is a fraction, negative 1 over 1. So, okay, think about the pieces. Y-intercept of 3 means I'm going to be right here. Slope of negative 1, rise negative 1, run positive 1. So down 1, right 1, down 1, right 1, down 1, right 1. So on and so forth. I'm doing lots of extra points. I hope you can see some of them. Again, that's positioning my line, isn't it? You figure out what piece of that line you need. So we need our line to go from 2 to 4. Well, we already talked about 2, didn't we? When x is 2. And then there's x equals 4. So we need the piece of that diagonal line that goes from the x equals 2 line to the x equals 4 line. Does your piece look like my piece? Okay. And the question becomes, what kind of endpoints does that segment get? It's just 2, less than x, less than 4. There's no equal to. So they are both going to be open pieces. Okay. Okay. We still have to do domain and range, but that's what your graph looks like. It's 3 random pieces. Some filled in endpoints, some open endpoints. Okay, ready to talk domain? What do we know about domain? It is how far the graph runs left and right. It is x values, yes? Now, there's two ways to do domain, and I'm gonna kind of make them work together. Officially, what I'm gonna go through, we should be looking at the graph. But there's kind of a shortcut that your domain is gonna match up with these x values, because that's what this is, okay? This right here, those end up being your domain values. Now, the difference is, my answer on here, and I assume this is what Sophos did, because that's usually what I try and do in my notes, is interval notation. So, okay, think about this graph. As I start coming from the left, where does my graph first exist? At what x value?
Negative.
And it first exists at -4, correct? So -4, comma. Okay, so now my graph is existing, existing, existing. Where does it stop existing?
Negative 1.
It takes a break at -1, yes? So the first piece is going to be -4 to -1. Now, around these -4 and the -1, we have to answer our questions of, are these parentheses or brackets? So, at -4, is -4 included?
No.
No, so we use a parenthesis. Okay, so anytime it's just less than or greater than, you're using parentheses. At -1, is -1 included? Yes, it's a filled in circle, or it was equal to up here, so then we're going to use a bracket. Okay, so anytime they involve equal tos, those involve brackets. Now, I'm not done because I have more graph to go, yes? Okay, so, okay. At -1, I'm using this pin here, my graph stops touching. When does my graph start back up? At what x value?
0.
Starts back up at 0. Does that match?
Yeah.
It does. Is 0 going to have a parenthesis or a bracket?
Perfect.
It's a bracket because it does not touch, or it's a bracket because it does touch. It's a filled in circle. Okay, now let's see what happens. Okay, so we're following this red line. It exists, it exists. It stops at 2, but what else happens at 2?
The next one starts.
My light blue line starts, doesn't it? Now, if neither dot was included, we'd have a break. But here, this dot is included here. Even though this dot isn't, the number 2 is included. So rather than just go 0 to 2 and take a break, we can say, okay, it's 0, going to 2. As we keep going past 2, where does it stop? At 4. So this one, we can say 0 to 4. And that's because even though it's two separate lines, there was no gap in numbers. Okay? We have something going to the left of 2 and something going to the right of 2. Parentheses or bracket on 4? Parenthesis. It's not equal to, it's not filled in. Now, do you see how this follows this domain up here? -4 to -1. Oh, hey, that's my first piece. Then it's 0 to 2, but then immediately 2 to 4. We combine those, and thus 0 to 4. So you can kind of get your domain from here. I'm not going to argue that. Okay? I'd like you to be able to look at the graph too, in case you have a graph and you don't have this to look at. But this will help you get your domain if you have it. Yes?
If the 2 on the red was an open circle, would we then have to make a third?
Mm-hmm. Yeah, if we didn't have a 2 circle filled in, we'd have to do a 0 to 2, a 2 to 4. Yep. Okay, let's talk range. Domain is left and right. Range is up and down. So now we're going to start with, okay, how low? So as we start going up, what's the first y value we encounter a piece of graph? And the first piece of graph I hit is,
-2.
okay, this bottom of this red piece, which has a y value of -2. Bracket or parenthesis with -2? bracket because it's a filled in circle, yes? Okay. Look for the next point that a graph doesn't exist. So as I'm going up, okay, we've got the red, the red ends, but my light blue is going on, isn't it? So something, you know, even though the red stopped at 0, my light blue is going on, so I can keep going up. When does my graph stop existing? That is a y value of 1. Okay, so -2 to 1, parenthesis or bracket.
See.
It's an open circle there, so parenthesis. And, okay, we're going up. When does my graph start existing again?
3.
We have that horizontal line at 3. It's a horizontal line. What's always its y value? Always 3. So this is an unusual one because does it go 3 to something? I mean 3 to 3, I guess, if you really wanted to. But we just list a single number there. Now, I don't think it'll let you list just a single number. So if you need to put something around it, there's a couple different ways we could do this, but I have written down here brackets. So I'm guessing if you run into that situation, Savas uses brackets, is why I'm guessing I put brackets here. I've really talked about the fancy squiggly braces, but I don't think they use them. Okay. It's work. I'm not going to argue. However, I will, on the flip side of that, argue, you know how to do all these individual pieces. It's putting it all together. Okay? So in my brain, it's doable because it's just looking at all the small individual pieces. Okay, you ready to try the next one? Okay, let's try the next one. So, first piece was first. Y equals 1/4 x plus 3. What do you know about 1/4 x plus 3? We have a y-intercept and we have a slope. Okay. We are confident in our x and y axis, I hope. There's your x. There's your y. So a y-intercept of 3 says we're going to do what?
Start at 3.
Yeah, we're going to go up 3. I just realized I don't really want to do a dark dot yet until I see where I'm going with this. Okay. I have to do a little bit. And then what's a slope of 1/4 say? Rise 1, run 4. So I'm going to go up 1, over 4. Now, if you go back and look at that, that's not taking me the right direction, is it? I don't really need to be going to the right. Excuse me. So instead of up 1, right 4, I can also go down 1, left 4. Okay, and again, you're not going to need all these pieces. It's part of me teaching it. Where do I need this to be? I need it to go from x values of -2 to 0. Now, interesting because we don't have a dot at -2, do we? But think logically. If I'm going over 4, if I go down 1 over 4, halfway through, if I only go over 2, that's going to put me in the middle, yes? Can you think that through? Because if we're going down 1, halfway across the 4 is going to put us at 2, so you'd be in a halfway point. So if we need -2 to 0, I only need that little piece of the string. The other points can be gone, or leave them there as long as they're tiny. What kind of endpoints did you put on this? On -2, it's not equal to, So open circle. On 0, it is equal to, so filled in circle. Okay, next piece. What do you know about y equals 2?
It's just gonna be
Straight line. If it helps you to think y equals 0x plus 2, go for it. But that slope of 0 means it's a straight line, y-intercept of 2. So now let's see, where's a y-intercept of 2? Up 2, straight line. So, you know, I keep going overkill on these dots, but that's the placement of the line, yes? How much of that line do we need? We need that line from 0 to 4. Okay, so I need that line there. The rest of this was excess. What kind of endpoints are you putting on 0 and 4? Not equal to, so open circle and then close because it's equal to. That's good because that one I kind of went over, so I need it to be a closed circle. It's hard to draw that small little piece. And I know your boxes are smaller, but you're using pencil instead of a fatter tip, but still. Okay, one last piece, yes? Y equals, now, it says 3 minus x. How do you guys feel about 3 minus x? I know I tend to flip it around. And when I say flip around, mx plus b, so x first. So I tend to say y equals negative x plus 3. Y-intercept of 3, a slope of negative 1 again, right? So y-intercept of 3. It's right there where I already have a point. Slope of negative 1. Have we done this a couple of times today? Down 1, right 1, 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 so on and so forth. Where do I need this?
4 and 7.
I need that piece of the line, and I have dots there, yes, from 4 to 7. Okay. Endpoints from 4 to 7. At 4, I need open circle. At 7, I need closed circle. Okay. We will need to talk about domain and range on this problem. We're probably going to do that Monday. But your thoughts real quick. Do you know where you're going here?
Oh,
Domain?
it's like all connected, isn't
It is all connected, but let's see, are there any, I don't know. So what do we have?
it?
It's negative 2 to 0, 0 to 4, 4 to 7 if we're looking up here, yes? Because we could use this for domain. Is everything included? So let's see, negative 2, going over to 0. That has a point here, doesn't it? So we keep going, 0 over to 4. That's included there. So now we keep going down here on the blue line, 4 over 7. What just happened? Oops. It is all included. Parenthesis,
Please.
bracket, we'll do range Monday.
Today we are going to